welcome. I will be representing my team. We will be detecting malware with kernel behavior analysis. Why behavioral analysis? The landscape of cybersecurity is constantly shifting, with malicious software becoming more advanced and evasive. Understanding the why behind behavioral analysis is crucial for modern defense strategies. We have three different kinds of behavior analysis: the present challenge of evolving cyber threats, limitations of traditional signature-based detection, understanding behavior-based detection as a paradigm shift. The evolution of malware. We have three different kinds of malwares: evasive tactics, zero-day exploits, and sophisticated attacks. Malware frequently employs encryption, polymorphism, and metaphorism to alter its code, making it unrecognizable by static signatures. Zero-day exploits. These threats exploit unknown vulnerabilities in software, meaning no signature exists for detection, rendering traditional methods ineffective. Sophisticated attacks. Modern malware can adapt to its environment, delay execution, and hide its malicious intent until the specific conditions are met, further complicating detection. Kernel system calls. The foundation, we have three different kinds: privilege separation, system calls, and behavioral fingerprints. At the heart of behavioral analysis lies the operating system kernels and its interaction with application through system calls. This fundamental layer provides invaluable insights into software's behavior. Privilege separation, kernel mode, the most privileged mode with full access hardware and memory where the OS core resides. User mode, applications run here with restricted access requiring system calls for privileged operations. System calls, these are the programmatic interfaces through which user mode applications request services from kernel, such as I/O files. Process management and network communication, they are the gatekeepers between software and hardware. Behavioral fingerprints, malicious and benign software exhibit distinct system call patterns. For example, ransomware might involve numerous file encryption calls, while spyware might focus on data exfiltration-related calls. Malware detection architecture, we have three different kinds: instrumentation, feature extraction, and classifier. This kernel behavior analysis relies on sophisticated architecture that can capture, process, and analyze the system call in real time to identify anonymous or malicious patterns. Instrumentation, hooks or agents injected into the kernel to intercept the log system calls. Collector feature extractor gathers raw system call data and extracts relevant features. Example, frequencies, sequences, and arguments. Classifier uses machine learning models to analyze extracted features and determine if behavior is malicious or benign. Unveiling malicious patterns, we have four different kinds. Sequence-based analysis, engrams, analyzes the short sequence of calls, engrams, to identify common patterns. Strength, simple, captures local behavioral patterns. Limitations, high, false, positive, struggles with varying execution paths. Hidden Markov models, HMM, model system call sequences as probabilistic state transitions, model effective for temporal modeling, better handling of variable execution paths. Machine learning, ML classifiers, utilizes various algorithms, SVM, random forest, on features like call frequencies, arguments values. Strengths are good generalization, interpellability. Limitations, future engineering overhead can be tricked by mimicry attacks. Deep learning, DL models, RNN, LSTMS, process raw system called sequences capturing complex temporal dependencies. Strengths, robust against mimicry, automates future extraction. Limitations, high compositional cost, large data requirements, black box nature. We need to choose the right tool. Each analysis method offers distinctive advantages and disadvantages. Selecting the most appropriate approach depends on the specific threat model and available resources. The engram, simplicity, speed for known patterns, high false positives, limited adaptability. HMM, temporal modeling, probabilistic inference, complex training scalability issues. Classic ML, interpretability, good generalization, feature engineering, vulnerability to mimicry, deep learning, robust against mimicry, automated feature extraction, high compositional cost, large dataset need, black box issue. Hybrid detection systems, combining the different detection methodologies, offers a more comprehensive and revolutionary defenses against the sophisticated malware. Hybrid approaches leverage the strengths of multiple techniques. Signature-based, quick identifies known threats with high accuracy. Threat intelligence integrates external feeds of known malicious indicators and attacks campaigns. Behavioral monitoring detects unknown and polymorphic threats by observing actions. Network traffic analysis monitors communication patterns for command and control C2 or data exfiltration. Static analysis examines file structure and code properties without executing to find suspicious characteristics. Current challenges: implementation. Despite its promise, deploying kernel behavior or an analysis in world scenarios presents several significant hurdles that need to be addressed for widespread adoption. Performance overhead. Real-time system calls monitoring can consume significant CPU and memory resources, impacting system performance. False positives. Distinguishing between legitimate and malicious activities can be challenging, leading to alerts for normal system operations. Mimicry and evasion. Sophisticated malware can emulate to benign as software behavioral or use anti-analysis techniques to bypass detection. Dataset quality is the lack of diverse, up-to-date and labeled datasets for training machine learning hinders accuracy. We have conclusion and future directions. We have 4 different kinds of them. Kernel behavior analysis is indispensable for detecting zero-day and polymorphic malware, offering a dynamic defense against evolving threats. The future of its field lies in continuous innovation and integration. The first layer is multi-layered hybrid detection, which is integrating statics, network, and behavior analysis for holistic defenses. The second is hardware-based monitoring, utilizes hardware features, example CPU performance counters, for more secure and efficient monitoring. Continuous learning models, models that adapt and learn evolving malware activity and system behavior in real lifetime. Adversarial and resistant ML, developing machine learning techniques that are robust against evasion and mimicry attacks by advertisers.